Hello and welcome back to another video for IGCSE Physics where we do some revision for paper 6. We have discussed some tips for planning, precautions, and a lot more. If this video does help you, please give it a thumbs up and subscribe. Let's begin. Alright, now we can start the video. First, we will discuss how can we do planning for the planning question. Okay, according to the syllabus, so the first step is that you're supposed to identify the independent and dependent variable. Describe and explain why variables should be controlled, appropriate number and range of values for the independent variable, and then the apparatus. So what does this mean? First, let's identify the independent variable. Remember, independent variable is the variable that you are changing. Dependent variable, on the other hand, is something that you are measuring. A dependent variable depends on the independent variable. You basically have to identify the relationship between both of them. Now, you need to show that you're doing at least 5 values. Then it's a good idea to also mention the apparatus. Now, a point to note is that you don't have to answer them like this. You can write like a paragraph, or you can like write points and write your steps accordingly. Okay, so here are some examples. The first one is, remember, read the question properly to identify what are your variables, because they will be different for every question. Now, so for example, we can say that the temperature was changed through these values using a thermostatically controlled water bath. Now for that experiment, let's say if you were using a water bath, not necessarily a water bath every time. Another point is that current was varied using a variable resistor to these values. Remember this important point, a variable resistor is used when you want to vary the current of the circuit. Another way to change is that you can change the voltage of power supply. That is also going to change the current. You can also write it this way, that use 5 wires of different diameters measured using a micrometer. So you're not specifically mentioning the values, but you did say that you're using different diameters. Another question, you can also mention that, for example, the experiment was repeated using nickel wire, chromium wire, etc. Okay. Now, dependent variable. For example, if you're measuring temperature, you will use a thermometer. If you're measuring time, you can use a stop clock. And remember that this is measured at constant intervals. For example, every 30 seconds. Now we can have a look at what are the control variables. So control variables are something that is controlled during the experiment. Make sure that you're only measuring the relationship between these two variables. A third variable is not affecting your results. So for example, if you are investigating the cooling of water, how does temperature reduces with time? So make sure that the initial temperature of water is same, volume of water is same, and you are measuring time after equal intervals. For example, after every 30 seconds. If you have an experiment related to a pendulum, this one, the length of pendulum should be same, this length of the string, because if the length is more, the amplitude will be greater. The mass of the bob and the angle of release, this one, it should be same. There was another experiment related to electrodes. So as you can see here, 2 electrodes are dipped into a liquid or an electrolyte, and how does the distance between 2 electrodes affect the current? In this experiment, the control variable is going to be the depth of immersion of these 2 electrodes, the volume of liquid, the electrolyte in which the electrodes are dipped, and the type of liquid. All of them should be same. Okay, next you have to describe the experimental procedure, identify risks and suggest appropriate safety precautions, describe how to record the results, process the results, and make predictions. Now we can do the method plus drawing. If you can, it's a good idea to draw it. For example, something like this. You can draw it with the apparatus, okay, and label it appropriately. So if you are drawing, the first step would be set up apparatus as shown in the diagram. And then you will write down your steps, okay, according to the question. Then you will say repeat the experiment 3 times and find the average value. So for each independent variable, you're going to repeat the experiment. For 5 degrees Celsius, you will repeat it 3 times. 10 degrees Celsius, you will repeat it 3 times. So repeat the experiment 3 times and find the average values. The next step would be, you can also include some precautions. For example, avoid parallax error, avoid zero error. And then finally, you will plot a graph of both values and compare the results. If applicable, you will also write the formula. So this depends on every question. You can even mention safety or risk. However, there are some questions that don't ask you for safety precautions. For example, in this question, they're saying no need to mention. Some safety precautions are if you're dealing with hot objects, you can use heat-resistant gloves. You can also use safety goggles depending on the question. If you have electrical experiment, do not touch bare or hot wire. Make sure that the surface is not damp. Switch off when you are changing the components. For example, if you're removing the ammeter, adding in a voltmeter, make sure that the circuit is switched off to reduce the chances to get an electrical shock. Another example, if you're dealing with mercury thermometer, careful that the thermometer does not break because mercury is toxic. Okay, so a student investigates the change in resistance of a lamp filament when the current in the lamp is increased. Okay, so can you identify the dependent and independent variable? We are changing the current, so the independent variable is going to be the current. What are we measuring? The dependent variable is the resistance. Now, the following apparatus is available: a power supply, low voltage filament lamp, ammeter, voltmeter, and connecting wires. Other apparatus are normally found. Plan an experiment to investigate the change in resistance of the lamp filament when the current in the lamp is increased. We're increasing the current. What happens to the resistance? Now, in the marking scheme, they did not mention about control variables, but if you do want to write, you can say one example would be use the same filament lamp. Resistance is given by the equation R equals V over I. So in this question, we are measuring the voltage and current to find the resistance of the lamp. So this is our diagram. Okay, so we have a circuit with a filament lamp. We have a voltmeter across. Remember, voltmeter is always across the lamp and ammeter is always in series. I chose a variable power supply. Why did I choose a variable power supply? Is because we are going to change the current. So if we change the voltage, we can change the current. Next, explain briefly how to do the investigation, including how to change the current. Okay, so the first step is set up the apparatus as shown in the figure, this figure. And the second step is turn on the power supply. When you turn on the power supply, the current will flow through the lamp and it will give you a reading for ammeter and voltmeter. So measure the reading. Now calculate the resistance. Now we're going to repeat this experiment for increasing currents, because as they mentioned in the question that we are the current in the lamp is increased. Okay, 5 times. How are we going to increase the current? To increase the current, increase the voltage of the power supply. Okay, now let's look at the next step. Now draw a table or tables with column headings. No need to enter any readings in the table. Make sure when you are doing it, use a ruler to draw it properly. And then don't forget your units here. This is going to be resistance in ohms. Now, the next step is how are you going to use your readings to reach a conclusion? To do that, whenever you have something like this, you can plot a graph where y-axis is the dependent variable. So for us, y-axis is going to be resistance and the x-axis is going to be current. Another way to read your results to form a conclusion is by comparing the values in the table. You can see that, okay, when the current is increasing, what is happening to the resistance? Is it increasing or reducing? So you can also say compare the values in the table. This is mentioned in this marking scheme. Now, another very important concept is called limits of experimental accuracy. This is one of the most repeated questions. You cannot get your results to be exactly same when you repeat your experiment. But they told us that the results are equal within the limits of experimental accuracy if they are within 10% of each other. If these two numbers are within 10% of each other, they are equal. So let's look at this question. State and explain whether your results for the focal length are equal within the limits of experimental accuracy. So in this paper, they calculated the two focal lengths, which were 15.6 and 14.9. Let's calculate, are they within 10% of each other? There are different ways to calculate that. One way is that find the difference between the two, 0.7. Then find 10% of larger value, and we get 1.56. Now, since 1.56 is greater than 0.7, they are equal. So here we can say yes, they are equal. Why? Because you can show this calculation and you can say that they are within 10% of each other, as mentioned in this marking scheme. Now let's move on to another concept, which is significant figures. The number of significant figures should be the same as the least number of significant figures in the raw data. This simply means your significant figure should be same as the question. If in the question they have two different types of significant figures, for calculation, use the one that has least number of significant figures. For example, if one is 2.1, the other is 2.63, your answer, when you did some calculations, your answer should have 2 SF like this. 2.1. Okay, if you look at this question, they did oscillations 10 times and they asked you to find the time period, so divide this by 10, you got 1.91. Now you're supposed to t-square. When you t-square, you got 3.4681. That is a lot of significant figures, but if you look at the question, we have 3 SF, 3 significant figures, so this one will also be 3 significant figures. This would be 3.65. Now what about another question? Here you're supposed to find the voltage and resistance. To do that, first let's find out the current. So we got 0.377, but remember, for calculation it should be same as the least number of significant figures. We'll write our answer as 2 significant figures, so this will be 0.38 ampere as mentioned in the marking scheme. Now we can find our voltage. When you have a table like this, you will make sure that your values are uniform. So this is going to be 2.6 and this is going to be 6.84. Both of them have, this one has 2 significant figures like the previous voltage values, and this one has 3 significant figures based on the previous voltage values. Okay, now we can move on to decimal points. Remember, decimal points represent the precision of the measuring device. So they said that the data recorded reflects the precision of the measuring instrument. That means what is the smallest difference that can be detected by the scale. For example, 20.2. This is 20.2. We cannot write 20.20, we'll only write 20.2 because this is the smallest difference that can be measured. Now let's look at this question. So what is the voltage here? 2.2, 2.4. 1 decimal point. Why? Because this scale measures up to 1 decimal point. On the second one, we have 0.5 amps. But we will not write 0.5, we will write 0.50 ampere. Why? Because this measures up to 2 decimal places. This is going to be 0.4248 and this will become 0.50. All of them have 2 decimal places, as mentioned here in the marking scheme. Now if we want to find the resistance, this equals to 4.8. So we will write 4.8 ohms. The significant figures should be same as the question. This is, so our answer also has two significant figures. Sometimes we have to interpolate between two readings. For example, when a reading lies between 2 scale marks, it should be interpolated to the nearest half division. So if you look in this question, the lower meniscus reads somewhere in between 21 and 22. So you will write 21.5 ml. You don't have to mention whether it's 21.3 or 21.4. No need to figure about that. If it's in between, it's going to be 0.5, nearest half division. So we can say significant figures is the same as data values in the question when you're calculating. But remember, if there are different significant figures, your final answer will have the lower significant figure. Decimal points are the same as the precision of device. Smallest difference that can be measured by the device is represented by decimal point. Now let's move on to tables. When you are doing your tables, you have to include the quantity. Are you measuring, for example, if you're measuring the charge, write slash coulombs. You will not write 2C, 3C. No need to mention the unit anymore. And to appropriate decimal point according to your question. Now, what if you have a graph? Whenever you have a graph, remember important points. X-axis is the independent variable. Y-axis is the dependent variable. Your graph should cover more than 50% of the entire space. Remember the formula of gradient equals to y2 minus y1 over x2 minus x1. You can just identify 2 points and draw a triangle. This triangle should be marked on the graph. Triangle should extend over at least half of the length of your line. That means it should cover at least half of your entire line. You cannot draw a smaller triangle here. Also, one more important thing is that your gradient should be 2 to 3 significant figures. If you have a curve, you can also find out the gradient by drawing a tangent and then draw its triangle, okay, to find the gradient. When you're doing experiments, you will be faced with common errors, and what are some precautions that you should do? Alright, so the first experiment is ray tracing using pins. What are some precautions to increase accuracy? View the bases of the pin, because if you look at the top, the pin is going to be thick from the top and thinner from the base. So look at the base of the pin, not the top of the pin. Make sure that the pins are vertical. Next, use sharp pencil. If you don't use a sharp pencil, your results will not be very accurate. And then make sure that the pins are far from each other. Another experiment. This is a thermometer in a beaker. You're measuring probably the heating or cooling of a liquid. You make sure that you're viewing the scale of the thermometer at right angles to avoid parallax error. Now, generally in questions, when you mention avoid parallax error, don't just say avoid parallax error. Write how you can avoid it. Okay, so this is important. View scale at right angles. Next, before taking reading, make sure that you stir it with the thermometer. This helps to distribute heat evenly. Next, make sure that the thermometer does not touch the side of the base of the beaker, because over there the temperature might be different than the whole liquid. Next, wait until the reading becomes constant or stops rising so that maximum temperature is recorded and you get accurate results. This one is for whenever you're using a thermometer in general. Now, if asked for some improvement, you can say use a lid so the heat is not lost to the surrounding. Stir it so to distribute heat evenly, and use a thick insulation such as the bubble wrap around the beaker. This prevents heat loss to the surrounding. Okay, now if you have a lens experiment, something like this. What if they ask you how to improve accuracy, particularly for the focal length? You will say to use a larger object, because if you use a large object, you will have a large image. Otherwise, it will be too hard to measure the height of the image when the object is small. But if we're talking about some general precautions to increase accuracy, make sure that when you have a ruler here, read the ruler at right angles to avoid parallax error. Another precaution is to make sure that the screen, lens, object, all of them are perpendicular to the bend. On top of that, all of them should also be at the same height. If they're not at the same height, this could cause some problems. Next, if you want to have a sharp image, conduct the experiment in a dark room, use a bright lamp, and if applicable, for example, in the question, if they are moving the screen or the object, move it back and forth until you get the sharp image. Now, you have to be careful what are they moving in that question, because sometimes if you say move object, but they are moving the screen, you will not get the mark. Okay, so take care of that. Next, if we have a spring experiment, something like this, we have a spring and a load is attached, and you're supposed to measure the increase in length. Again, make sure that avoid parallax error by looking at a right angle to the scale. Make sure that the ruler is very close to the spring and is also parallel to the spring. Use a set square, that helps as well. Next, before taking any reading, wait for the spring to stop bouncing. If it's bouncing up and down, it's going to be very hard to get an accurate reading. Now we can have an oscillation experiment as well. In oscillation, we have a pendulum. We have a bob hanging from a pendulum. It's moved to a certain height and it's allowed to swing back and forth. So when the bob moves to the maximum height, it can be hard to identify what is the maximum height. So to record time when the pendulum passes through the center. So this goes there, there, and maybe back there. Maybe you can measure that time. Record time when the pendulum passes through the center, because it's hard to know the maximum amplitude, the maximum height at which the bob rises. Use same length of pendulum when repeating, because length of pendulum can affect the amplitude. Now, if you want to calculate the length, when we calculate the length, we calculate the length of the pendulum all the way to the center of the bob. But how can you measure the center? Take care when you're measuring the circumference, use a thin string. Then to calculate until the center of the bob, divide circumference by 2. Now, most of the times in the experiment, you don't measure the time for the ball to come back once, but you do it after 10 oscillations. Why? Because this reduces the effect of error due to reaction time. In one oscillation, the time is so less, there will be some error due to the reaction time. Now, if you have some electricity experiment, one of the precautions that you can take here is that in electricity, the wire becomes hot, and this increases the resistance. When the wire is very hot, the atoms are vibrating so fast that the electrons cannot flow easily. There is increased resistance, and it can affect the result. So make sure that the current is low. Don't carry out the experiment with very high currents. Current should be low, and whenever you're taking the reading, turn off the current. Turn off the switch, turn off the current when reading, so that you give some time for the circuit to cool down. If you look, I equals I squared R. If the current is high, the power lost as heat will be high. So use less current, so less heat is dissipated. Now, there was this question in specimen paper 23. So basically in that question, a student did an electrical experiment, and another student had to replicate it. But they were saying that there was some difference in the values calculated. What are some of the sources of errors, or what are some reasons why there were differences in the answer? You can say because it's difficult to judge the exact position of the crocodile clip. If you don't know what a crocodile clip is, look it up. It's going to make it clear for you. It's difficult to measure wire to the nearest millimeter when you're measuring the length of the wire. Sometimes the contact between the wire and clip is not precise. Also, it can also be difficult to interpolate reading between graduations. For example, something like this, 1, 2, 3, 4, 5. If you were measuring this reading, it can be difficult to identify the exact one. Now, another source of error when you're measuring volume using a measuring cylinder is to take care of the meniscus. When you're measuring the volume of liquids or water, take the reading according to the lower meniscus. But for mercury, take the reading for the upper meniscus. Next, generally, always take multiple readings and average them. For example, for oscillations, for any kind of experiment, take multiple readings and average them. Especially true for the planning experiment. Make sure that you are repeating at least 3 times or more. Digital scales are always more accurate to read than analog. Why? Because there is no parallax error. Remember the one here. You don't know what exactly is the reading here. You will avoid that with digital scales. Next, avoid parallax error and zero error. How? Always mention how. Okay. So when you're avoiding parallax error, read scale perpendicularly or at eye level. Read scale perpendicularly or eye level. And zero error, make sure that the first reading, the initial reading is 0. For example, if you're using a digital balance, make sure that the mass is 0 when you have nothing on the balance. Another common way is sometimes when you are measuring using a meter ruler, sometimes it does not start from the beginning. This is 0, this is 1. But if you put your object like this and you start measuring from this one, you will get the wrong reading. You have to put your ruler from 0 position, okay, to avoid zero error. Now, and one more lastly, please make sure that you review all the electrical symbols. These are mentioned in the syllabus. Go through them and also learn how to draw them.